So today we are tasked with the challenge of finding the critical point, the critical point, which is A, as well as whether the function is increasing or decreasing, and whether they're concave up or concave down here. So step one would be to identify A. To do this, we have to find f prime of x, which is just the derivative. And this equals, we use the chain rule, so it's going to be 7 times 2/3 times x minus 4 to the negative 1/3. And this equals 14/3 times x to the x minus 4, to the negative 1/3. Yeah. And then we're going to have to equal this to 0. So let's just come over here, do 14/3 times x minus 4 to the negative 1/3 equals 0. So this is separated into two different parts, which is just do that. 14/3 is equal to 0, which is undefined. And then just simply x minus 4 is equal to 0. We just solve real quick, add 4 to both sides. And that equals, let's do this, x is equal to positive 4. And that's going to be our critical number, 4. So now that we have that, let's just rewrite these as negative infinity to 4, and then 4 to positive infinity, now we need to determine if f of x is increasing or decreasing on each of these intervals. Negative infinity to 4 and 4 to negative infinity, so we're going to test the point on this one first, from negative infinity to negative 4, I'm sorry. And I think for this we can do x equals 0. So we can do f prime of 0, and that's going to equal to 14/3, 0 minus 4 to the negative 1/3. And this equals just simply 14/3 times negative 4 to the negative 1/3. Why does that keep popping up? And since this is going to be negative, it's going to make this negative, so we can just easily tell that in that point it's going to be decreasing. And then to test one on 4 to infinity, we can do, it's not negative 4. Wait. Yeah. So to test the point on from 4 to infinity, we'll just do f prime of 5. That's going to equal to 14/3 times 5 minus 4 to negative 1/3, and that equals 14/3 times 1 to the negative 1/3, and this just simplifies to 14/3. So from 4 to positive infinity, it's increasing. So we can tell that this graph is going to look something like this. It's going to go decreasing, then increasing. Now we need to determine the concavity, like whether it's concave up or concave down. So to do this, we need to find the second derivative, which is f prime prime of x, double prime of x, I don't know how you say it. Starting with 14 over 3 times x minus 4 to the negative 1, negative 1/3. So to find the derivative, we do the chain rule again. So it's going to be 14 over 3 times negative 1/3 times x minus 4 to the now it's negative 4 over 3. And this is going to equal negative 14 over 9 times x minus 4 to the negative 4/3. Okay, so now we need to do it on each interval like we did over there. So we'll first do negative infinity to 4, and then we'll do 4 to infinity. Excuse the ugly infinity signs. So let's just choose the same intervals, or the same points, test points. Do x equals 0, x equals 5. So right here we can do f prime prime of 0 is equal to negative 14 over 9 times x minus, times 0 minus 4 to the negative 4/3. And since 0 minus 4 to the negative 4/3 is going to be positive, it's just going to be a positive times a negative, so we can tell that on this point it's going to be concave down. And then we'll do the same thing for the other side. Let's move this a little bit over. Oops. So over here we'll do f prime prime of 5 equal, oh I hate this iPad, is equal to negative 14 over 9 times 5 minus 4 to the negative 4 over 3. And this will simplify to 14 over 9. This is just 1, so it's just going to be negative 14 over 9 still. So since it's negative, it's also concave down. So our final answers is A is equal to 4, critical point, and negative infinity to 4 is decreasing concave down, and from 4 to infinity it's increasing also concave down.